Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to go over radical and simplifying radicals with variables. So we have here like 30 problems. I don't think we need all 30, but also there is a small caveat that I want to talk about. Uh, Maybe when we reach one of these problems, probably when we go to number 4. Um, So, when you take the radicals, especially the square roots in this case, all of them are square roots. So, what is the meaning of a square root? So, for example, when I say square root of 25 is 5, what do I mean? I mean that the number 5, when multiplied by itself, so 5 times 5 equals 25, right? Because the square is the inverse of the square root. Notice I multiply two fives to get 25. So when I take something from underneath the square, I have first to see, are there two numbers when multiplied together would give me this value? Because if it does, then I'm lucky. I'm going to take this number and it would be the answer. If that doesn't make sense to you, let's look at the first problem. The first problem says the square root of 128 x to the 4. First of all, I learned my multiplication table. I know not there is no number that when I multiply by itself, I will get 128. I can get 9 times 9 is 81, 100, 121, which is slightly lower, and 144, which is above. So there is no number. So what do I do? That's the first question. The second part is easy because when I have a variable, I know from when we covered exponents, we said if I multiply a base with an exponent by itself, I add the exponents or I double the exponent, right? Again, when I say x cubed times x cubed, 3 and 3 is 6, so the answer is x to the 6. X to the 5th times x to the 5th is x to the 10th, which means when I go in the opposite direction, all I have to do is to divide the, the exponent by 2. If it's even, I'm lucky. And in this case, it is even. It's x to the 4. So I know when I take it out, it will come out as x squared. But what do I do with the radical, with the number 128, which is not a square? First of all, let's do it the long way. I'm going to say I'm going to take the 128 and find its factors. So if I have 128, let's write it here. And if I divide it by 2, I get 64. Some of you will jump and say, oh, 8 times 8 is 64. Yeah, that's fine. But I want to show you something. I'm going to divide it by 2, I get 32. Divide by 2, I get 16. Divide by 2, I get 8. Divide by 2, I get 4. Divide by 2, I get 2. Divide by 2, I get 1. So I have 1, 2, 3, 4, 5, 6, 7. Oh my God. I should have picked something else. 7 twos. Every two of them, so when I say square root of 128 equals, every two identical factors come out as a single one. 2 and 2 times 2. 2 and 2 times 2. Oh, a single 2 stays under the radical. 2 times 2 times 2 is 8. So 8 radical 2 is 120. That's how simple it is. So this one would be, the 8 is outside like the x square, so I'm going to write 8x squared, and there is a 2 inside square root of 2. Help me with the second one. Square root of 98a. Okay, here's the same piece of paper. Square root of 98. I'm going to take the 98. It's even, so I divide by 2. I get 49. I stop. There is no reason to say, well, 49 is 7 times 7. There is nothing else. So 7 square root of 2. 7 the square root of 2. How about the a? Well, it's a single a, so I cannot divide it by 2. I cannot divide the, here I divided the 4, the exponent, by 2, and I wrote it out. If I divide by 2, I get 8 to the 1 half. Wait a second. We learn in exponents is that 1 half is the square root. So I didn't do anything, so it stays inside because it's odd. Only when it's even, I can take it out. Now, let's move to the next one. Square root of 320. I know there is no square root of 320. It's not a perfect square. So what do? I keep this reducing it until I find the square. So it's an even number. I divide by 2. That's 160. I divide by 2. Notice that some of you already know where I'm going, right? You should have found that because you can see the 16. Anyway, I'm going to divide by 2, so it becomes 80. Divide by 2, it becomes 40. Divide by 2, it becomes 20. Divide by 2, it's 10. Divide by 2. Oops, I'm stuck. The 5 comes only once. 2 and 2, it's a single 2. 2 and 2 comes out as a single 2. 2 and 2, they come out as a single 2. So 2 times 2 times 2, we know already it's 8 because we did it here. So 8 square root of 5. So this would be 8 times the square root of 5, and the n is to the power of 1 also has to stay. So that's the simplification. Now we have to be careful with the next one. Well, I think in Algebra 1, you don't worry about that. Here we're going to say, assume positive variables. Say, what does that even mean? I'll tell you what it means. Suppose that V, I wrote it as new, but it's V. And let's suppose V is negative 3, which means V square is positive 9, right? Do you see what happens when I take the square root of 9? What is the square root of 9? It's just 3, not plus or minus 3. So when I'm solving for V, if V originally was negative and I squared it, it became positive, and then I take the square root of 9, it becomes positive 3, not negative 3. But if I write the answer is V, because the square root of V squared is V, that would be wrong because V is negative 3, I said, not 3. But when I squared it and then took the square root, it became positive. So that's why we say it is the absolute value of V, not V. So why this problem happened again? Because I took a value that was negative, but it was squared. I didn't know that it's squared. They gave me V squared. They didn't give me V. They didn't tell me that V is negative. So I said, okay, V squared is under the radical. The square root is V. And I say the answer is V. They say, no, we started with negative V. But how did you end up with V? I say because the square root of a number is only the positive, the principal root, which is V. So they said, so okay, make sure you write it as an absolute value of V, so we don't say the answer is V. The answer is the absolute value of V, not V. V is negative, but the answer is positive. So my answer is the absolute value of V. Now, I know that might be a little confusing. You will, I think in Algebra 2, we'll discuss that. But for now, if you are taking the square root of a variable and the root is even, like square or to the 4 or to the 6 or to the 8, and when you divide the exponent by the root, this is 2 and this is 2. 2 over 2 is 1. So you get an odd answer. You have to use the absolute value. So these two have to work. If this was a cube root, I wouldn't mind. Why? Because the cube root, say, of -8 is -2. I can get a negative answer. That's fine. If 8 is positive, I get 2. If it's -8, I get -2. So I don't care about an absolute value. I don't care. But all of these are square roots, meaning the root is 2. There is a hidden 2 here. And if this 9, or like we said, if I say the square root of v square again, when I divide 2 by 2, I get 1, which is odd. So I use the absolute value. Only when it's odd, you use the absolute value. So to get away with this problem, I said assume positive variables. So all the x, the n's, the v's, and m's, all of them are are positive variables. So I don't worry about using the absolute value. Let's come to the 294 v square. 294. It's not a perfect square, okay? So 17 square is 289 and 18 square is 324. So it's not. But I see it's even, so I divide by 2, I get 147. 147 is odd, so it's not divisible by 2. But it might be divisible by 3. Let me add 1 and 4, 5 and 7, 12. Yeah, 12 is 1, 2, meaning divisible by 3. So I'm going to divide it by 3. Divide 14 by 3, I get 4. And 27 by 3, I get 9. Oops, the familiar 49 again, meaning 7, 7, 7, 1. Two sevens, right? Two sevens. So it's 7, and under the radical, 3 times 2 is 6, stays inside. Both the 2 and the 3 stay inside. And I have v squared, so I'm going to say 7v times root 6. Notice I didn't use the absolute value because I assumed that all the variables you see on this sheet are uh, positive. Okay, let's move to the next one. And now I think you already got the gist of it. Square root of 72. 72 is odd, even, so 2 is a factor. We get 36, which is 6 times 6. So 6 root 2. Do you see that? 6, 6, 6, 1. Two sixes come out as a single 6, and the x squared come out as an x. So 6x square root of 2. 6x square root of 2. This one, we already know that the square root of 294 is 7 root 6. X cubed is x squared times x. So only x squared come out as x. So x times x times x. The first two come out as a single x, and the other one stays under the radical. So for the numbers, I get out 7, right? I got it here. For the x cube, I get x outside and x inside, square root of 6x. Notice that when you take the from under the root, every two x's, meaning x squared, come out as a single x. When you do the other way around, every x go inside as x squared. So x squared times x would be x cubed. And the 7 goes outside, inside as 7 squared, or 49. And 49 times 6 will give you 294. I think these are that is again a repeat. So the square root of that is 6 square root of 2, and then the n cube goes out as an n, and there is another n inside. And that's the difference between these two. There is an extra n or x. If that was x cubed, I would have another x inside. I think we should go more to, I mean, we skip few because, I mean, it's a waste of time to do the same thing over and over again. Let me see if we have, maybe we did what, 7, and there are 30. We need 8 more, right? So let's see if we skip 3 and do 4. So if we do 11, 15, 19, 23, 27, these would be 5, another 6, 7, 8. Okay, let's do these. Square root of 32. You should know that this is 2 times 16. But if I have 6 times the square root of 32n, the n stays, right? Because it's a single n. There is no n squared. I'm worried about the 32. 32 divided by 2 is 16, but 16 goes out as 4, just to save time. So 4 outside, 2 inside. 4 outside, but I already have 6. So 6 times 4 is 24, and 2 stay inside 2n. Okay? So this would be 24 square root of 2n. Let's do 15. Negative 7 times the square root of 18n cubed. N cubed goes out as n, and inside there is another n. Let's see what do we do with the 18. 18 is even. If I divide by 2 and there is a negative sign, I get 9. 9 is 3 squared. So I get 3 times 7. So at the end of the day, I get 3 out. Times 7 is 21, but it's negative. So negative 21. I have 2 inside, n cubed. So n outside and n inside. This would be the answer. Negative 21n times the square root of 2n. 19. I have negative 8 square root of 24x to the 4. X to the 4 will come out as x squared, right? So I don't have to worry about that. I worry about the 24, which is even, 12, which is even, 6, which is even, 3. I have 2 2's come out as a 2, and inside I have square root of 6. So negative 16x squared, negative 16x squared, square root of 6 of 6. There is no x because x to the 4, all of it came out as x squared. Go to number 22. 3, 4, 3, which is 7 cubed, by the way. You should learn your cubes until 10, for example, or 12, whatever. U square v cube. If you keep dividing by 7, you will get 49 times 7. So it's 7 square root of 7. The u squared come out as u. The v square of it comes out as v, and the other v stays inside. So 7uv square root of 7v. 7uv square root of 7v. With the numbers, you take the roots. With the variables, you divide the even power by 2. Or if it's odd but more than 2, you divide the 3 by 2, right? You get 1 and 1/2. 1/2 meaning square root, so it stays inside. The 1 comes out as the variable. Number 23, 147. We did the 147 before, right? It was 3 times 7 times 7. So it comes out as 7 root 3. Comes out as 7. And the x squared comes out as x. The y to the 4 comes out as y squared. And notice we said this is 7 times 7 times 3. So the square root of 3. Right? 147 is 7 root 3. 7 root 3. X squared is x. The square root of y to the 4 is y squared. Again, if they didn't tell you these are positive variables, but I think you don't have to worry. Or every time you see x or u or v or n, you have to put them between absolute value signs. But again, it's okay. Uh, 100x to the 4 y to the 4 is a perfect square. Square root of 100 is 10. Square root of x to the 4 is x squared. Square root of y squared is y. Y to the 4 is y squared. So the 10 comes out and make the 330. 3 times 10. There is no square roots. X squared, y squared, and no absolute value even. Because even if x or y are negative, their square would be positive. But there is a negative sign outside, which make the final answer negative 30 x squared y squared. 27, 252. Let's do that. So if I have the square root of 252, I say 252 is even, so it's divisible by 2. 126 is even, divisible by 2. 63 is not divisible by 2, but it's divisible by 3. 21 is divisible by 3. 7 is only divisible by 7. So I have a 2, I have a 3, which is 6 root 7. So the number will give me 6 root 7. How about the variables? Oh, I'm sorry, and it's multiplied by 7, by negative 7. So here I get negative 42, which is the negative 7, times the positive 6, and a to the 4 would give me a square, b square will give me b, and then under the radical, I have 7. Notice it was 6 root 7, and I had negative 7. So negative 7 times 6 is negative 42 root 7. The a to the 4 came out as a squared, the b squared came out as b, and that is the answer. Sometimes people don't like it like that. So in other words, if you put the numbers together, why do I write it like that? I could have said this better to be written as negative 16 root 6x squared. And this is 7 root 7 times uv square root of v. And this one is negative 42 root 7 times a square b. 7 root 3 times xy squared. Negative 21 root 2 times n root n. Or I can, since there are two roots, I can leave it like that. That's okay. But it's preferable to write the number 7 root 6 times v and 8 root 2 x squared. Okay, but if there is a root that has both, you can leave it, that's fine, like this guy. But it's preferable to have the numbers first, then the variables. And the last one we have, negative 4 times the square root of 175 a square b to the 4. Let's look at the number first. 175 ends with 5, so it's divisible by 5. You will get 35. Divisible by 5, you get 7. So 5 root 7. Negative 4 times 5 is negative 20. Right? Root 7. And then the a squared comes out as a, and the b to the 4 comes out as b squared. So negative 20 square root of 7 ab squared. Notice that there is no square of a or square root of b, so I can combine all the numbers first, then the variables. I hope this was easy enough for you to see. All what you have to do is like a direct application of factoring. You take a number or a variable and you keep factoring it And it's the square root. Square root meaning square root, you multiply two things by a thing by itself twice. So every two comes out as one. If I make that a cube root, then all three come out as one. So like I said, the cube root of 8, I divide 8 by 2, 4 by 2, 2 by 2, 1. There are three twos, so they come out as a single 2. Fifth root, or every 5 come out as 1. 10th root, every 10 come out as 1, and so on and so forth. So it's really not hard. It's just more tedious, more work to do. So again, if you have any question, like I prefer, again, as I said, to write the numbers next to each other. So 6 root 2x, that makes more sense than to write it 6x times root 2, right? The numbers first, then the variable. But if they are combined, I can either leave it like that or say 6 root 2 times n root n. Well, two roots in the same expression. It's better since I cannot separate numbers and variables. I leave it as it is. Like this one, I leave it as it is. Um, but it's better, as I said, if they can be separated, like these guys, write the numbers first, then the variable. It's not wrong to leave it like that, but it doesn't look nice. Okay. If you have any comments, as usual, as I tell you, you don't hesitate to send me a note. Otherwise, I hope to see you tomorrow. Have a nice day.